If you've ever moved before, you know that you can accomplish the move using a car and taking a ton of small trips. But most of the time, you're going to find it easier to rent a giant box truck and do it all in one go. That's what we call using the correct tool for the correct job. And while substitution can be a great way of solving these linear systems of equations, we're going to find that elimination can be just as, if not more effective in the right situation. So let's take this system of linear equations. We could solve this using substitution. And in fact, equation number 2 here would be a pretty good candidate for substitution. But let's say that we chose equation 1 and we said we're going to go ahead and solve for x. Great, so now we know the value of x in terms of y, and so we could take that and plug it in for x in our second equation here, solve for y, and figure out what point these two equations intersect at. Doesn't that seem a little challenging though? I think so. So one of the things that you want to look for is, one, is substitution even going to be easy? In this case, yeah, I'm not thinking it's going to be that easy. But then look for opposites. So opposites make it really easy for us to use a method called elimination. So what we're going to do now is we're going to pick one of our equations. I'm going to just pick equation 1 to be kind of our main equation. And I'm looking at it and I'm saying, you know what? If I could just get rid of this 2x, I'd just be left with y's in the equation. So how might I do that? Well, I know that I can do whatever I want to one side of the equation as long as I do it to the other. So I'm going to take this piece of equation number 2 and I'm going to add it to the left side of the equation. Well, that's going to do a great job of eliminating my x's, and it's just going to leave me with a negative y on the left. But now my equation is no longer in balance. However, I can just add the same thing to the left side and my equation will be in balance. But wait a second, if I add that over to the right side, I'm going to end up with x's on the right side, and I was trying to get rid of those. I've done such a good job already. What could I do instead? Well, if I look to my equation here, I know that negative 2x minus 4y is the same thing as negative 16. So I can replace negative 2x minus 4y with negative 16, and I will still keep my equation balanced because I have added the same value to both sides. There we go. Now that I know the value of y, I just need to find the value of x. I can pick either equation, it doesn't matter which one, to find that value. In fact, a good way of checking your work is to check using both. So now I'll go ahead and substitute in 9 where y used to be and solve for x. And now I'm almost done. As I mentioned before, we are looking for a point of intersection, so we need to write this as a point. And I now know that these two equations share the input and output negative 10, 9, and that's where they will intersect. We now have a secondary algebraic method for solving systems of equations. So we have two tools and we can decide which one's best depending on our situation.